Today's topic in fluid mechanics, previously we already learned about the chapter 4, which is dimensionless analysis. Now we go to chapter 5, continuity and Bernoulli's equation. For this video, I will give introduction on continuity and Bernoulli's equation. So the objective of this study, this chapter, is to acquire fundamental concept and application of continuity and Bernoulli's equation. So the learning outcomes for this chapter, at the end of this chapter, students should be able to, 1, define and derive continuity and Bernoulli's equation. Second, state Bernoulli equation in 3 different forms, in forms of head, pressure, and energy. But in our calculation, normally we will use Bernoulli's equation in terms of head. Third is discuss the limitation of the Bernoulli's equation. For the beginning of the Bernoulli's equation, we have some limitation because we know that the Bernoulli's equation can be used in so many different equation or different situation. And at this point, for this chapter, this is introduction to Bernoulli's equation. Therefore, there are some limitation on the Bernoulli's equation. Fourth, apply the Bernoulli's and or continuity equation to solve fluid mechanics problems. Sometimes we are only needs to use Bernoulli's equation in terms of solving the question, but sometimes continuity comes after the Bernoulli's because we need to solve Bernoulli's equation. Some of the unknown needs continuity equation to solve it. Fourth is explain vena contracta, and then the last learning outcomes is discuss and calculate coefficient of discharge, coefficient of contracts, and coefficient of velocity of flow through sharp edge orifice. For this introduction, we will go to understand about the calculation for the fluid mechanics. We will go through, first is mass flow rate, second is volume flow rate, and then rate of flow, or we call it as a discharge. Now we go to the first one is mass flow rate. So if we want to measure the rate at which water is flowing along a pipe, a very simple way of doing this is to catch all the water coming out of the pipe in a bucket over a fixed time period, measuring the weight of the water in the bucket and dividing this by the time taken to collect water. This to collect water gives a rate of accumulation of mass. When we are talking about rate, there is what we call as per second. In your question, in your solution will have per second. This rate of accumulation. This is known as mass flow rate. So if we refer to this statement, we can actually calculate the mass flow rate of this water. As we know that the water has been collected by the bucket and over a fixed period of time. Therefore, we want to find what is the mass flow rate is equal to mass of fluid in a bucket, over time taken to collect the fluid. For example, in this example, an empty bucket weighed 2 kg. After 7 seconds, this is the time taken to collect the water. So after 7 seconds of collecting water, the bucket weighed 8 kg. So this is weight after the bucket has been filled up by the water after 7 seconds. So we cannot take 8 kilograms as our mass of water because we know that the empty bucket weighs 2 kilograms. Therefore, what we need to do is we have to minus 8 with 2 kilograms. Therefore, we will find the value, the weight of, not weight, the mass, the weight of the water, okay, mass of the water. From here, we can minus 8 minus 2 kilogram, and how long we will, this water has been collected? 7 seconds. Therefore, we need to divide by 7. So this is a simple equation in order for you to determine what is the mass flow rate. Normally, in your calculation for a fluid mechanics, we will use this equation, mass flow rate equal to density times with velocity times with the area. Okay, this is density of fluid. For example, we have water flows in a pipe. So this is pipe, we have water flows in a pipe. Therefore, in order for you to determine what is the mass flow rate, so you have to multiply density. This is density of the fluid. We have the fluid, water, for example, water, and then we know that the fluid density for the water is 1000 kilogram per meter cubic. And now velocity depends on the question. If the question mentioned that the velocity of water is 2 meters per second, therefore you substitute here 2 meters per second. Then what about A? A here is AC. I change into AC. What is AC? AC is a cross-sectional area. How to determine or how to calculate cross-sectional area? So if we can see from the front side, this is from side view, and if we take a look at the front, okay, front view, so we look at here, and then that is what we call, we cross this figure, and then we take a look at the front view. So I will go here. So we have front view of the pipe. So when we are looking at the front view, we will see these kinds of figure or these kinds of shape. So this shape is actually shape of this water from cross-sectional area. So therefore, we want to find what is the cross-sectional area for the pipe. So we have been given the diameter of the pipe. In the question, the diameter of pipe will be given. So diameter of pipe will be given, for example, 4 centimeter. Okay. So in order for us to find what is the cross-sectional area, we know that to find the cross-sectional or the area of the pipe, so we can see here, this is a circular shape. We know that for the circular shape, we have to use pi r square. This is radius. So radius we have from center to wall of the pipe is r. If we want to use radius, then we have to use this equation, pi r square. But if you want to find in terms of diameter, you don't want to change, because normally in the question, diameter will be given. Therefore, in order for you not to change it into radius, therefore you can use this equation, change it into diameter, because we want to substitute directly the diameter. So we know that radius, to find radius, diameter must be divided by 2 square. Therefore, this equation turns into pi d squared over 4. You can use this equation. You may not need to change diameter given in the question into radius. It will take some time. But if you wish to convert the diameter to radius, it's okay. And then after you calculate by using the pi d squared over 4 for the cross-sectional area, then you will substitute into this equation, okay, to find what is the mass flow rate. So mass flow rate unit is kilogram per second. So from here we know when we substitute the unit for density is kilogram per meter cubic, and then times with velocity unit is meter per second, times with unit for the area is meter square. So we can cancel out this. So meter times with meter square, it will be meter power of 3, and then meter power of 3 will be cancelled out with meter cube. Therefore, your unit for mass flow rate is kilogram per second. So this is your unit for mass flow rate. That is calculation for mass flow rate. Then we go to the volume flow rate, discharge. So sometimes in the question, it will not ask you how much volume flow rate, or how much volume flow rate. Sometimes they will use, please calculate discharge rate. So discharge rate, volume flow, and volume flow rate are the same. Okay, so you have to remember that volume flow rate is equal to discharge is equal to volume flow. Okay, so more commonly we need to know the volume flow rate. Okay, this is more commonly known as discharge. Okay, when the question asks you to calculate discharge, therefore that question asks you to find what is the volume flow rate. It is also commonly known inaccurately simply called flow rate. If the question asks you flow rate, then it is also asks you to find what is the discharge of the flow. Okay, the symbol normally used for discharge is Q. Remember, Q is discharge for flow. Okay, the discharge is the volume of fluid flowing per unit time. Multiplying this by the density of the fluid gives us the mass flow rate. Consequently, if the density of the fluid in the previous example is 850 kilogram meter cubic, okay, per meter cubic, then, and this example refers to the previous example here. So we have 850 kilogram per meter cubic for the density of the fluid. Then to find the discharge, so we know that discharge unit is meter cube per second. So meter cube per second is discharge unit. Q unit is meter cube per second. So meter cube is volume, and then divided by time taken. So volume of the fluid divided by time, V over time, and then here we have mass of fluid divided by density times with time. Why? Because we know that to find density, if the density, only density information given in the question, so we know that density is mass over volume. Am I right? So in order for you to determine what is the volume of this flow, therefore you need to rearrange this equation to, so volume equal to mass divided by density. Therefore you will get this equation. Okay, substitute into this equation, you will get mass of the fluid over density. Now we have time. So if we substitute into the equation, it will be mass of fluid. So it will be divided by density divided with time. We know that when we divide with time, it will turn into mass of fluid okay, divided by density times with 1 over T. Therefore, you will get the same equation as here. Okay, so we know that the mass flow rate from the previous example is 0.857 kilogram per second. Therefore, you need to substitute into this equation in order for you to determine what is the discharge. Okay, density is already been given in this question, 850 kilogram per meter cubic. And the time taken for the flow is 7 seconds. But here, as we can see here, volume is mass over rho. Now, mass of fluid over time is mass flow rate. Take a look at here, the equation. So, mass of fluid over time is mass flow rate. Therefore, we change this equation into mass flow rate over density. Therefore, you have to only take mass flow rate and divided by 850 kilogram per meter cubic, and you get that the discharge rate or discharge of this flow is 0.001008 meter cube per second. Okay, this is simple ways on how to find the discharge. Normally, we in the question, fluid mechanics question, we are using rate of flow or discharge. Rate of flow also known as discharge. Okay, so sometimes determine what is the rate of flow, flow rate, discharge rate, volume flow. All of that refers to discharge. So which means refer to meter cube per second, the unit for that discharge. Okay, so rate of flow or discharge is defined as the quantity of fluid flowing per second. Okay, quantity of fluid meter cube per second through a section of pipe or channel. It is generally denoted by Q. Okay, let us consider a fluid through a pipe. So this is a pipe, and then the fluid flow through the pipe. And then we have A, area of cross sections of the pipe, and U bar. Here we can see that U, we have velocity bar. This bar means that this velocity is average velocity. We know that when we are dealing with a pipe, previously we already learned that if the fluid flow on the flat plate, for example, okay, flow on the flat plate, okay, we know that when the fluid approach to the flat plate, there will be no slip condition phenomena occurs on flat plate, okay, on the flat plate surface, and it will affect to the other layers, then it will become velocity profile. So it will form a velocity profile, and it is the same concept as what we learned before in the pipe. What happened in the pipe? We have fluid that sticks on the wall of the pipe inside. Okay, it will form a velocity profile in a parabolic manner. So you will see these kinds of figure when you learn about the Hagen-Poiseuille equation. You will find that the velocity profile in the pipe is parabolic. So what does it relate with velocity? So when we want to calculate the velocity of the flow, we have to take out U average. We cannot find the U for every layers. Therefore, if you want to find what is the mass flow rate, or you want to find what is the discharge rate, you have to use U bar, which means average velocity. All this velocity in each layer will be summed up and then will be average. Therefore, it will go to U bar. Okay, you will see this U bar for so many times after this, because in the pipe we are taken U bar, okay, average velocity. So in order for you to find what is the discharge from this pipe, so you have to use equation Q equal to area times average velocity. As we can see here, area is meter square, the unit, times with average velocity is meter per second. When you multiply with these two, you will get meter cube per second, which is unit for that discharge, okay, meter cube per second. Okay, so here area is cross-sectional area. You cannot take out the area for this pipe, surface area. This is surface area. Okay, we are not dealing and we are not interested in calculating the surface area of this pipe. We are interested on this area because the fluid flows at this area. Therefore, you have to come up with cross-sectional area, not this. This is AS. Okay, this is surface area. We are dealing with a cross-sectional area because the fluid only flows on this pipe. Therefore, the area will be cross-sectional area. So what is the cross-sectional area equation? As I mentioned before, I already explained to you the cross-sectional area will be pi r square. Or you can use another equation where we don't want to use radius as our terms in the equation. Therefore, we change it into diameter because we don't want to convert diameter to radius. Therefore, you have to change radius because to get radius, we have to divide diameter with 2 and square. So AC is equal to pi d squared over 4. This is the area that you need to calculate in order for you to substitute into discharge equation. Okay, rate of flow equation. This area represents cross-sectional area. So you want to find discharge rate, you have to multiply cross-sectional area with average velocity. So you don't have to worry because in the question normally it will state that it will state the velocity, and that velocity represent average velocity. In the question, it will never state that average velocity in the pipe is 2 meters per second, for example. Question will state that the velocity of a fluid in a pipe is 2 meters per second. So that velocity represents average velocity. Therefore, you take that velocity and times with the cross-sectional area. Therefore, you will get what is Q, discharge. Okay, so here, if the area is in meter square, as I wrote down here, so meter square times with meter per second, so you will get meter cube per second. Okay, so that is the equation for introduction in continuity and Bernoulli's equation. You will always use this equation in your calculation for Bernoulli's and continuity equation. So please remember and memorize the equation in order for you to answer the question in continuity and Bernoulli's equation. Okay, thank you.